Good morning. This question is from section 11.1, which is inference about two population proportions. Though this question is actually specifically asking about what size of a sample do we need to do an experiment. So let's go ahead and figure that out using StatCrunch. This is actually a useful process to do for designing a survey or other experiment where you're trying to determine how large of a sample you need. So a physical therapist wants to determine the difference in the proportion of men and women who participate in regular sustained physical activity, and they're trying to determine the sample size to obtain within 5 percentage points with 99% confidence. And those two things are actually really important to be able to calculate. So 5 percentage points is our margin of error, and then 99% confidence is our confidence level. So there's two different scenarios. One is if we have prior estimates, and one is if we don't. So we're going to do this in StatCrunch, and the instructions for it are also in our StatCrunch how-to guide on our Blackboard site in section 11.1, determining sample size. So I'm going to go through this right now, where we're going to go into StatCrunch and use proportion stats to sample power/sample size, and then we'll look at the confidence interval width. So StatCrunch. Okay, so here's StatCrunch. We go to Stat, we do proportion stats. This is two samples because it's men and women. And we're going to do power/sample size. Okay, so to do this, we need to choose confidence interval width. Our confidence level is 99%, so 0.99. Our first proportion is 21.9%, so that's 0.219. Our second proportion is 18.4%, that's I always double point that, 184. Now the width is plus or minus this 5 percentage points. So we have to take that number, 0.05, and double it. So the width is 0.1. And we're looking for the sample size. So the sample size in this situation, where we're using prior estimates from the previous year, is 853. And then for the second one, when we look at that, it's what happens if we don't have any prior estimates. And when we don't have any prior estimates, you need to assume that there's a 50-50 chance. So 0.5. The width is the same. It's, oh, I did that. 0.1. That's right. It just rounded. So 0.1, and we hit compute. And so the sample size, when we don't know, is going to be larger. 1327. So the reason you pick 0.5 is because that gives you the largest possible sample size. So this is the largest sample size that you would choose if you didn't know if you didn't have a prior estimate for your proportions. Okay, I hope this helps.